B10. B10 is a little bit longer one as well, so we'll talk about this, right? So now here we're looking at 3 different hydrocarbons, right? They're all kind of related to each other. We have acetylene, which is C2H2. We have ethylene, which is C2H4. We have ethane, which is C2H6. And so now, right, the question is, drawing the atomic and hybrid orbitals for each, carbon atom of each one of them. So if we draw out what C2H2 looks like, right, that's a triple bond between the carbons in this case. And so, right, if we go through, right, these guys are sp hybridized, so they're going to have, the little balloons there. They're going to be opposite, right? And you're going to have the balloons that are pointed towards each other, right? So each one of those carbons has 2 sp hybridized orbitals, and those form the sigma bonds. And then you have, the pi bonding interactions that are forming the triple bond in that case. For C2H4, right, that's a double bond between the hydrogens. So now each one of those carbons, right, has 3 sp2 hybridized orbitals in these cases. And so the way that then looks, right, is that you have the little balloons, right, that are pointed towards the hydrogens. And balloons that are pointed towards themselves, right? So these are all, right, the SPs, and then these are all the sp2s, right? And then now you have one pi bonding interaction in between those, right? So those are the pi's. And then for C2H6, right, these are all going to be sp3 hybridized, right? So it's just all balloons at this point, right? So it's like, right, and so each one of those carbons has 4 sp3 hybrid orbitals, right, that are forming the sigma bonds in those scenarios. And so B, energy required to break chemical bonds. I feel like there was something that I got cut off from that question that I didn't catch or any of the TAs caught. Anyways, in which of the 3 hydrocarbon molecules would the least amount of energy be required to break the carbon-carbon bond? Explain or justify your answer, right? So in this case, it would be the C2H6, because the C2H6 is a single bond. So there's only, the only bond that you have to break is the sigma bond in that case. Whereas in the case of C2H4, right, you have to break the pi bond, but then you also have to break the single bond, right, the sigma bond in that case. And in the case of the acetylene, right, you have to break the 2 pi bonds, and then also the sigma bond in those scenarios, right? So that's, requires a lot more energy to start, to break 3 bonds or 2 bonds compared to 1 bond, right? And so that's why it's C2H6.